to JMath.
In this video, we are going to look at trig functions again, but in this time, they are going to give you the sketch and you must find the equation. So once again, these are the rules. You can take a screenshot and study them. It works for sine, cos, and tan. So to find a, I know a is plus if the graph is normal, but if it's flipped, I need to put a minus in front. I can just see how far the graph's stretched, but if it is a bit tricky, I can use that formula. So maximum minus minimum, and that answer divided by 2. So let's look at Q. It works very much the same, but this time everything moved up or down. So I can just check how far it moved from the normal graph. And if that's a bit tricky, I can just use the formula max plus min divided by 2. To find the B value, there's going to be a lot of clues to what the B value is. But the easiest one is to check what is the period, and then say B is equal to 360 divided by the new period. For sine and cos, and for tan, it would be 180 divided by the new period. Another trick with tan is you can just check the distance between the asymptotes, and that would give you the period. And then I say 180 divided by that amount. Now, to find the p-value, I would just check if the graph moved left or right, and then it is always opposite. So if it moved left, p is positive. If it moved right, p is negative. Let's look at the questions. In recent years, they would always give you a standard formula, and then they would show you which variables you need to find. Now remember, they are not always going to be nice and make it an A and a B and a P and a Q. They are going to put in other letters of the alphabet, so you must really know what each position stands for. Not just A is this and B is this, the position of where it is. At the end of the video, we're going to do tricky questions where it's not just an A and a B and a P. But let's look at fx first. So in this case, I can see there's an A value that changed and a Q value that changed. So I know the normal sine function goes up to 1 and down to -1. But in this case, I can see something changed. So firstly, I'm going to try and find Q. A sine graph normally starts from 0 and then goes up, back to 0 and then goes down. So 0 is normally the middle of the graph. But in this case, they were nice to give me a dotted line and tell me it's -1. So I know the Q value in this case is -1. Now I just need to figure out what's A. So I can use the formula that I showed you guys. So I can see it is a sine graph. It's the right way up because it goes up first and down at the end. So I can just say A is equal to the maximum Y value minus the minimum Y value over 2. So that gives me 4 over 2, and I can then therefore say it's 2 sine x minus 1 as the answer to this question. I could have also just seen if the middle is -1 and the top is +1, it's stretched by 2 in this case. So whichever way you like, you can use to find the formulas. Question 2 is now a tan graph, which I need to find the A value and the B value. So let's go for the B value first. I can see those asymptotes are not on their normal place. So it should have been 90, but now it is 45. And the other one should have been on -90, and now it's on -45. Remember, at the beginning of this video, I said the period of a tan graph is the distance between the asymptotes. So I can just say the period is 45 minus -45. So this one's period is 90 degrees. Now to find the B value, I can just say B is equal to what it should have been, 180, divided by what it is now, and therefore the B value is 2. It's squashed by a factor of 2. Now the A value, that can be a bit tricky. So I'm going to show you 2 ways to do that. The first one is I know that on a normal tan graph, there should be a dot that says 45 and 1. And that's normally what I use to find the A value. In this case, the 45 is halved, so it's 22.5, but the Y value is doubled. So the Y value is 2 in this case, and that means the A value is 2. Okay, but I know that could be a bit tricky. So the other way you can do this is to fill in what you have. So I am looking for A, and I know B was 2. Then I can search for any dot that they gave me and sub in the X and the Y to find A. So that is always your backup plan to use. So in this case, Y was 2. I don't know what A is, but tan would then be 2 times 22.5. And I can then just type that in my calculator and then see that's actually tan 45, which I know is just 1. And therefore my A value is 2. You can either look at the graph to find A or then use the calculator. So just to end off, GX would be equal to 2 tan of 2x. Question 3, they clearly show me what they want. So let's look at the A value. I can see this graph, the middle moved a bit up. So I can immediately say Q is +1. And now I need to see what A is. So from the dotted line, it went 1 up and 1 down. So I can clearly see A is 1. But something else is bothering me. This sine graph is upside down. So it looks more like a cos graph. But remember, they shifted a bit to the left. And that's why it's there to confuse you. Because this number 3 and number 4 almost look the same. But it started at -135. So don't let them confuse you. This is an upside down sine graph. So I can say A is -1. Sine, and now I just need to figure out how far this moved left or right. So remember, a normal sine graph has its first turning point on 90 degrees. So there's no B value, so I know it should have been 90, but now it moved to 45. So this graph moved 45 degrees to the left, so it must be a +45. And that is the equation of this specific fx. Let's look at gx. So in this case, they didn't change my a value or my q value, but there's a b and a p. So once again, look closely at where the things are situated, because that's going to change the way I do the sum. So normally, if there's a b value, it should be cos b and then x minus p in a bracket. In this case, they didn't give it to me like that, so I must just be wary of what's happening here. So firstly, let's see what the period of this graph is. So the period should have been from 0 to 360, but in this case, it is from minus 10 to 110. So I'm just looking from one maximum to another maximum, and this distance is 120 degrees. So remember I said I can find the b value by saying what it should have been divided by what it is now, and therefore the b value is just 3. So I can say g of x is equal to cos of 3x, and now I must just see how far did this one move. The cos graph should have started on 0 and 1, but now it's at minus 10 and 1. So this one moved 10 degrees to the left, so I can say this is plus 10. I can overcomplicate this question, but I'm just going to stop there because that is what they asked me. Question 5. So I need to find an a value and a p value. I'm going to start with the p value. So a normal tan graph should start at 0 and 0. This one started 60 degrees to the right, so I know this is going to be x minus 60. Okay, it's 10, and now I just need to figure out what is a. So once again, I can use the algebra because I know there's a coordinate of 105 and 3, so you are welcome to do that. But let's try and figure it out without the calculator. So I just need to see how far did this graph go up from where it started to 45 degrees to the right. And I can see it went up by 3, and therefore my a value is just 3. Okay, like I said, if you're uncomfortable with that, just sub in the calculator and work it out in an algebra fashion. Question 6. Now it has a star next to it, so apparently it's difficult, but let's simplify it a lot. So in this case, everything changed. A, B, P, and Q. That doesn't happen often, but they want to trick us. So always start with the Q value. That's going to be the easiest. They are very nice to give me a dotted line. So I know Q is just plus 1. Now I'm first going to focus on the A value and just see firstly, is this sine graph upside down or is it the right way up? Okay, so they're trying to trick you once again because they moved it 90 degrees past the y-axis. So it looks like a normal sine graph. But remember, I am only looking at the part where it should have started at 0. And there it first goes down and then it goes up. So this is actually a negative sine graph. Now from the dotted line, it went 1 up and 1 down. So I know A is just minus 1. Now I just need to check what my B value is. And in this case, it's a bit tricky to find the B value because they don't give me this specific value because the first cycle is from there to there. And now I don't really know that value. So what I'm going to do is I'm going to look at half a sine graph. So they were very nice to give me this minus 5. So I know half of the sine graph is there, and that was 90 degrees. So it should have been 180, half of a graph, and now it is 90. So I know if that's half a period, then B should be equal to 360 divided by a full period, which is 180, and therefore my B value is just 2. Now I just need to figure out how far this graph moved, left or right. And now it's a very tricky part because the B is in front of the bracket. So I can see the graph should have started at 0 and 0, but it moved 5 degrees to the left. Now I can't just say P is plus 5 because there's a 2 in front of the bracket. So this must be 5 over 2. Okay, very tricky question, but that is the answer. Now, in exams, the trig function question can count anywhere between 7 and 15 marks because they're not only going to ask you just sketch and then they move on, or just what is A and B and then move on. They are going to give you questions about the graph. So let's do one like that and just see what they're asking us. What is the range of fx? Now, a big tip I want to give you guys, if you are allowed to, please use highlighters in your papers because that's just going to make things so much easier. So I can see they gave me a f function, which is a sine graph, and now I can just see there is an f, so I can just highlight this graph. So by using highlighters, I just simplified this a lot for myself. So it's going to conserve energy, it's not going to frustrate you so much, and then the question is so much easier. So what I'm also going to do is I'm just going to continue with the highlighting just to make it so much easier for my brain to figure out what am I actually looking at. Okay, great. Now I can do what is the range of fx, so the purple function. So remember, range is my highest turning point, the y value, and the lowest turning point's y value. So in this case, I can see it started on the dotted line of -1, and then it went up by 2. So therefore, it must also go down by 2. They didn't indicate this, but I can safely assume that this is going to be -3. Because this graph has an amplitude of 2, it must go 2 up and 2 down. And therefore, the range I can write as y is an element of block bracket -3 to 1. Close the block bracket. Now they're asking me what is A, B, and C. So I know A and B are on the purple graph, and then C is on the orange one. We just said that the amplitude of this graph is 2, so I can safely say A is definitely 2, and then B, now watch out. This is not the B that we were talking about in the beginning of this video and in the previous video. They are trying to trick you because this is actually in the position of Q, so that B affects if the graph moved up and down. So please just don't be stuck in B is always 360 divided by the period. In this case, it's going to really cost you marks if you miss that. So in this case, B is just how far did the graph move up or down. It moved down by 1 because of that dotted line on -1 that they gave me. So I can then say A is equal to 2, B is equal to -1, and therefore f of x is equal to 2 sine x minus 1. Please always just write somewhere on your page the actual new formula once I know everything. I see there's a typo on my question. It is not actually C that we're working out, it is D that we're working out in the tan graph. So what is the D value? Now, again, this is the number that's directly in front of x. So it's technically the B value, the one that is squashing or stretching this tan graph. Now, I must try and find that. And this is now hidden in the graph because they don't show me asymptotes. I drew in an asymptote, but I'm assuming where it is, so I can't use it. So what I'm going to do there is I'm going to use the coordinates of P. But now I need to look a bit further. They don't give me the coordinates of P, but I can see it's the turning point of the sine graph. And the turning point is normally at 90. Sorry, guys, I know this is tricky. But let's do the algebra method to do this. So it's y is equal to tan of bx, and I said that coordinate there is 90 and 1. I am just going to sub that in. 1 is equal to tan of b times 90, and then if I say shift tan of 1, I can then just say, okay, but this is then b times 90 equals shift tan of 1, and I know that is just 45. So then b is equal to 45 over 90, which is just a half. And there we go. That is my new formula. So I'm just going to jot it down there and tell them I know that gx is equal to tan of a half x. Now, please don't make the same mistake that I did. I am so used to writing a b. This is actually the d value that I worked out. So d is equal to a half. It's fine if in the middle you wrote a b, but please, at the end, please change it to a d because they must see that you know that you actually worked out the d value when they're marking this. Question 3 is now one of those questions where in an exam they want to really just trick you. Now, what is the range of y if y is minus fx plus 1? Now, please don't try and draw a new graph on this. Just take the range that we worked out in question 1 and then just manipulate like they're asking. So they are telling you multiply each y value with a minus and then plus 1 to that value. And if I just simplify that, I can see minus 3 times minus 1 is just positive 3, plus 1 gives me 4, and then the next part would just be minus 1 plus 1, so that is just a 0. Now please just rewrite it from smallest to biggest and tell them you know the new range will be y is an element of 0 to 4. Don't let them trick you with that question. You do not need to draw a new graph, just manipulate the previous range. Write down the equation of the asymptotes of gx. Now that is again with my tan graph, and I must now look at the formula. So the formula said it is tan of a half x. So that means everything is doubled. So the asymptote should have been at 90, but now it is doubled. So I can just tell them it is at x equals 180. Question 5 is also something you would typically see in an exam. For which values of k does fx plus k have no real solutions? So that ties in very much with functions and parabolas and things, but in this case it is a bit easier. Now, if something is plus at the very end of a function, it's just going to shift it up or down. So it's basically changing the q value. Now I can see the highest point of my graph is p, and that is at plus 1. The lowest point it is at minus 3. Now they are asking me, how can I move this graph up or down so that it doesn't have x-intercepts? So let me try and show you guys something. I can then move the graph down just by more than minus 1. Then it doesn't have x-intercepts. Or I can move it up more than 3 units, and then it won't have x-intercepts. So now I must just write that in mathematical terms. So to answer this question, I will say k must be smaller than minus 1, or k must be greater than 3, because I wanted to move down further than 1, or up more than 3. Question 6, they love putting in exams. For which values will the purple graph be above the orange graph? So here, colors are really going to help you. Now, I am going to check at each point of intersection on my graphs, and then just try and establish which one is on top. So I'm going to start from left to right at minus 135. I can see they intersect each other. Now, I want to know where is the purple graph, fx, above gx. Now, I can see it's left of that specific point. So my first answer is going to be x lies between negative 180 and minus 135. Now, very important, minus 180 will be an asymptote. So it does not get a little line underneath, but the 135 is not an asymptote, so that can get an including sign. That's one of my answers. Perfect. Now I'm going to check between these 2 points of intersection. Okay. So there the orange graph is on top. That's not what they are asking me. Then I need to look very closely. So there is actually a little piece where the purple graph goes above the orange graph, and that is between 45 and 90. So just checking for asymptotes, there are no asymptotes there, so I can put a line underneath. Then I'm going further to the right. So this part, the purple is not on top, but straight after the asymptote. So for this section there, the purple graph is on top, and the orange graph goes down next to the asymptote. So I also need to tell them from 180 to 225, but remember 180 is an asymptote, so it doesn't get a line. And that is all the sections where fx is greater than gx.
If this video helped you, please like and subscribe.
JMath.